So today I want to talk about one of the maybe sneakier uses of substitution. To integrate a function like this one, x divided by x minus 1. Now, I think this is one of the most frustrating functions to actually try and integrate because this particular function is quite difficult to integrate despite its simple appearance. We can't use the natural log because the natural log can only be used if the numerator is 1 or a constant. We can't um, we can't really do anything with this at the moment except for the following trick, which I'm going to show you. And this is a nice trick which is useful when the integrand contains x and a linear function of x. This trick can sometimes help you to integrate integrands of this format. For example, this function contains x in the numerator and x minus 1 linear function of x in the denominator. The trick I'm going to employ is this. I'm going to try to set u equal to the linear function. So in my particular example, I'm going to use a u substitution, and I'm going to set u equal to x minus 1, such that du dx is equal to 1, or in other words, du and dx are identical. So I'm going to go ahead and I'm going to go into this integrand. I'm going to attempt to rewrite the entire integrand so that it's in terms of u and not in terms of x. So, not x over x minus 1, but x over u, since u is equal to x minus 1. Not du, but instead let's replace it with dx, since they are equal to each other. Oh, rather, replace dx with du. Now, at first glance, it may seem like our substitution has failed, because after substituting x minus 1, after substituting dx with du, our integrand still has an x in it. So how are we going to get rid of that? But the idea here is that this substitution equation, u equals x minus 1, can actually be solved for x quite easily. I could rewrite this expression so that we have u plus 1 equals x instead of u equals x minus 1, which means that we can take the integral of u plus 1 over u du, and we have an integrand with no x's whatsoever. Now at first glance, this might seem almost as bad as the function that we started with. It's just that the weight has been moved to the numerator and it moved out of the denominator. But the fact that the denominator is only one term, actually that is what saves us in this problem. Because the denominator being only one term means it can be quite easily distributed. Divide u by u, and then separately divide 1 by u. So what am I integrating? Actually, I can rewrite this integrand so that I can integrate 1 plus 1 over u with respect to u. And this is a very nice and easy function to integrate. The integral of 1 with respect to u is just u. The integral of 1 over u is the natural log of the absolute value plus arbitrary constant c. And finally, we can go back and we can rewrite everything in terms of x. So everywhere we see a u, we'll put an x in that position instead. So we will write x minus 1 plus natural log absolute value x minus 1 plus c. That would be the integral of this function. And once again, you can go back and you can check. You can say, what is the derivative of this function? What is the derivative? And you will find that it simplifies to the original integrand that we have.